Okay, thanks for coming out, everyone. This is Customizing Chef for Fun and Profit. I've got everyone in the afternoon caffeine crash sugar drain session. So to wake everybody up and also to settle a question that's been running through the conference, we're going to do a little group participation exercise. What we're going to do, and you all have to do this, you all have to be with me on this or else I'm going to look really stupid on YouTube. We're going to wake up both this room and the next room. I'm going to count down from 3. When I reach 1, we're all going to drop the F-bomb as a group, really loudly. And it's going to wake you all up, and them as well. Okay? And you all better do this seriously. On 3. 3, 2, 1. Fuck! Aren't you all awake now? Excellent. Bet you any money that doesn't make it on YouTube. Just for the record, I stole that idea from John Allspaw, so it's totally legit. So this is Customizing Chef for Fun and Profit. This is me. I'm John Cowie. I'm an ops engineer at Etsy. For those of you who don't know who Etsy are yet, you probably have a female relative who does. We are an online marketplace for handmade and vintage goods, essentially. The way we like to put it is we enable you to buy good things from real people. Just to give you a couple of numbers, just to kind of let you know where I'm coming from. As of about mid-February, we were looking at about 30 million members, about 18 million items listed, 60 million monthly visitors, around about 1.5 billion page views a month. We are fairly well known for doing continuous delivery. This is a graph of site deploys on Etsy.com. So the yellow line you see is deploys of the actual main Etsy.com code base. So from about 10 a day in 2010, this is just after Allspaw joined Etsy, to round about a week ago, we're up to about 40 deploys a day of the main site code base. You see the blue line, round about mid-2011, we split out what we call site configuration deploys. The configuration file is things like feature flags, which sides of, so we use sharded MySQL, which MySQL's shard sides are in. So we split that into separate deploys, so they run parallel to main code deploys. So if you add both up, we're probably approaching about 80, 90 code deploys a day. We do continuous delivery with Chef as well. This whole philosophy's kind of influenced the way we think about Chef. So we use GitHub Enterprise. This is the GitHub Pulse graph for our Chef repository from about 2 weeks ago. One of the main workflow challenges that guides the way we use Chef Etsy is we have about 30 to 40 people regularly making Chef changes. So this is stats for a month, so 32 authors pushed 926 commits to all branches. Every single one of those commits was either a cookbook change, a role change, a databag change. It was changing an artifact on the Chef server. Chef at Etsy, we use open source Chef server. We have around about 1,500 nodes under management. They're all bare metal, which according to a talk this morning makes us an eccentric edge case, which I was kind of pleased about. So we don't have anything in the cloud. We have some asset storage on S3, but it's basically all self-hosted bare metal. Everything's CentOS. We have some Mac OS X Jenkins build slaves for integration tests for iOS apps and all that kind of stuff. And frankly, we love Chef, like we really do. It's a fantastic tool. It lets us do a lot of the stuff Etsy do, we can do because we have Chef to make us not worry about the automation side of things. And one of the reasons that we love Chef is that we know best. And to kind of demonstrate this thing, I'm going to need a volunteer from the audience who preferably does not work for Chef and did not speak at this conference. Anyone want to come up on stage and be famous for like 30 seconds? Somebody put their hand up. Man at the back there, come on up. Good to meet you. So this is Dimitri. He works for Everywhere. We are privileged to have amongst us possibly the world-leading expert in the infrastructure challenges of Everywhere. Round of applause for a world-leading expert in the room. Thank you very much. By way of demonstrating the point, I can't tell you how to run Chef in your infrastructure. I can't tell Dimitri how Everywhere should run Chef because I work for Etsy. I know quite a lot about Etsy's infrastructure, but that doesn't qualify me to tell you what to do with yours. And this is a philosophy that's shared by Chef as well. To quote Bruce Lee, this is one of the underpinning philosophies from Jeet Kune Do, which is a martial art he developed. Absorb what is useful and discard what is useless. One of the nice things about Chef, because Chef was designed from the ground up to be sort of It's essentially a generic solution. Like, it doesn't dictate to you one particular workflow or one particular way you think about your infrastructure. And and Adam Jacobs doing, I'm quite proud of this. He's doing basically the same kung fu hands as Bruce Lee. It took me like an hour of going through Adam's slides to find him doing the same hands. Adam said this. He said, "I'm not smart enough to build an ontology that can encompass all the variations in infrastructure. Nobody is. The world's too fast." That philosophy underpins Chef. The reason Chef does so many different things, and the reason there are so many different workflow tools like Bergshelf and Spark, is because everyone has different challenges. There's no magic pill. There's nothing in Chef that will solve all of your problems automatically. And at the end of the day, you are the expert. Every one of you here in this room, if you take anything away from this talk, is that you are the expert and don't do something just because I told you to, or anyone else for that matter. The other reason we love Chef is its customizability, and that's going to be the main focus of the talk. Because Chef isn't dictating to you how you should think about your infrastructure, it's by almost definition extremely customizable. You may have seen a diagram similar to this on the Chef website. This is basically the layout of how the Chef client tools and Chef server fit together. On Chef server, essentially, we don't need to care this exists. It's a data store. It's what they call a thin server model. As long as you know this is there, everything comes in through the web server at the top. You're basically talking to it as an API. And there's no business logic on the Chef server. It's a data store for your cookbooks and artifacts and so on. And apart from that, you really don't need to worry about it. It just sits there. Where all the logic lives is in the client tools, which is what they call the thick client, thin server model. All the business logic and all the actual stuff that happens goes on in the clients that run on your nodes. And what we're going to focus on today, because I only have 40 minutes and there's way more to customize in Chef than I can possibly fit into that time, we're going to focus on the kind of customizations you can do with Chef client itself. So that's basically everything up to the point of, we're not going to cover things like LWRPs and providers, again, because I only have so much time. What we're going to focus on is the way a Chef run fits together and all of the different places you can customize code and link in your own customizations to basically make Chef work the way you want it to. So this is a diagram of the anatomy of a Chef run. Don't worry if you can't read the text. We're going to basically go through it step by step. And at various points when we encounter customizations, we're going to pause and we're going to dive into them and just try and piece together how the whole thing fits in. So the first stage of a Chef run is get configuration data and initialize. This basically means loading client.rb, or if you're using Chef Solo, solo.rb. It loads things like the server URL, the client key you want to use for authentication, the path where your cookbooks live, where you want to store your cached files, and so on. And then the next thing that happens is it runs Ohai. For anyone who hasn't encountered it before, Ohai is the tool that gives you all those attributes you use in your recipe. When you use things like Node Platform or Node FQDN, those are collected by Ohai and basically given to you as part of the Chef run. And Ohai is powered entirely by plugins. Even the default stuff like Node FQDN and Node Platform, those are actually powered by plugins. And the neat thing about plugins is we can write plugins as well. So the first when you see something in blue, that basically indicates a customization point we're going to kind of swerve off and talk about a little. So Ohai plugins. Ohai plugins fundamentally add attributes to your node. When you think of your node as in the node object in Chef, if you want to add new attributes about anything, could be like what cloud platform you're running on, what day of the week it is, what you had for dinner. You can add that in Ohai plugins if you want to. I mean, I don't know why you'd want what you had for dinner, but you could. Ohai is executed right at the start of the run, so before anything else happens in the entire Chef run, really, Ohai is executed. And all plugins that Ohai knows about are also executed. Ohai plugins are a single Ruby file. What I mean by that is it doesn't use object-oriented Ruby in any way. It's literally just treated as if a declarative script. It starts from the top, goes to the bottom. Attributes set by Ohai. For anyone who's looked, there are, I believe, 15 attribute precedence levels in Chef, which, as we all know, is incredibly fun to deal with. Ohai attributes, or automatic attributes, have the highest attribute precedence level. So if you try and override Node Platform in your recipe code, Ohai will still win. It's like the top of the pile. Things set by Ohai are maximum precedence level because you basically don't want somebody accidentally changing your recipes to think the box is running on Ubuntu and it's actually running on Windows. This is what Ohai plugins look like. This is Ohai version 6, which is the current release version. This is a very, very simple plugin. We start off with a provides, it's technically a method call, but I'm going to call it a statement because I don't want to teach object-oriented programming as well. So we're just basically telling Ohai what attribute this plugin is going to provide. We're going to provide an attribute called awesome. We're then basically saying we're creating a new mash object for awesome to live in. Mashes in the Chef context are fairly similar to hashes in Ruby, except with a hash, if you have a string, the key is a string or the key is a symbol, that's two different things. Whereas in a mash in Chef, it's the same thing. They're treated as one is equivalent to the other, essentially. It just makes it a little bit easier to work with hashes. And then we're setting two kind of sub-attributes. Awesome Zos is Sriracha, because it is, and awesome level is 11. And what that will give you is, in your node recipes, you would then be able to say node.awesome level, or whatever. There are some weaknesses with this approach. You can't do multi-platform Ohai plugins very easily. You have to basically write a different plugin for every system you want to work with. Because this is basically treated as a declarative script, if you want to put that kind of logic in there, you have to do it yourself. So there's a new DSL being introduced in Ohai version 7, which is currently in beta. It's not actually out yet, but it will be fairly soon. And version 7 Ohai plugins look like this. So there's a little bit more structure. The actual plugin body itself lives in an ohai.plugin block, and we give the plugin a name. Same provides block. The main difference here is this collect data method. And what the collect data method is basically the entry point into the plugin. So when Ohai calls your plugin, it will call the collect data method. The neat thing is, here we have a collect data method with the symbol Darwin. You can have multiple collect data methods. You can have a different one for any platform, and you can also have a default one, which it will use if there's no more specific one to refer to. So what we would have here, if we were running this on a Mac, it would call the Darwin collect data method. If we define a collect data method with the symbol Linux, on Linux, that method would be used instead. So this basically makes it much, much easier for us to do, basically support multiple infrastructures in our Ohai plugins without having to do 4 or 5, 6 different files. Actually running Ohai plugins, making Ohai aware of them is really, really simple. You basically just add the path to your path where your plugins live to the Ohai config plugin path directory in client.rb or solo.rb. Stick a plugin file in that path, append a path to that array in your config file, Ohai will run your plugins, and the attributes will pop up on your node. So that deals with Ohai. The next stage of the process is authentication and registration. And what this basically means is we're saying, because much as when you run knife commands and you authenticate as a client, your nodes do as well. They have to basically say to the server, hey, I'm allowed to get cookbooks and stuff. So first stage is authenticate to the server using your client key, typically client.pem or something. If the node basically doesn't exist yet, as in if it's brand new, it will try and register against the server using a separate validation key. And if any of you have played around using Knife Bootstrap or anything, this is that validation.pem file that you end up putting on your boxes. Generally a good idea to delete it once the node's registered, because the cert doesn't do anything and you can register other nodes with it. If both of those fail, the Chef run will end at that point. You're not authenticated to the server. You are not an authorized node to get anything from the server, so the run will stop. Providing you've authenticated or registered, we'll continue on to the next stage, which is loading and building the node object. Now what happens here, first of all, Chef downloads the previous node object from the server if one exists. So when you do, say, knife node show and the name of your node, that's giving you like a pretty printed version of the node object stored on the server. Remember, the Chef server is just a data store. It also stores your node objects. So once you've downloaded the node object, that will be all the saved attributes and everything, all the, the run list and so on stored on the server. Chef client will then combine those attributes with the new attributes loaded when Ohai ran and basically provide sort of a new node object to represent the state of the node for this run. The next step is it expands the run list. As you may know, in Chef run lists, if you have, say, a role in your run list, that role can contain other roles, that role can contain other roles and recipes. And what this step does is that essentially expands this into just one list of what cookbooks and recipes you need. And in this is another very important thing in Chef. Order matters a crap load. The theory being, if you put recipes in your run list in a certain order, that is the order those recipes will run. There are occasional things to be aware of, like resource notifications that happen at the end of the run, but as a general rule, what you put in your run list will be basically run in the same order. And this is really useful, and this stage is basically what starts that process and guarantees that. The final thing that happens during this stage is Chef Client creates what's called the run status object. This is exactly what it sounds like. This is basically an object which represents the status of the chef run. We'll come on to this a lot later. We're not going to dive into it in too much detail at this moment. But this is basically the point where this object that we'll refer to later is created. The last step, sorry, that wasn't the last step, this is to run start handlers. Again, this is another customization divergence. Handlers in Chef are designed to respond to specific situations. There are pieces of code which respond to a particular situation that occurs during the run. They come in three varieties. One we're going to look at here, which is start handlers, and also report and exception handlers, which we'll look at towards the end because they occur ideally towards the end of the run. All handlers, regardless of type, share the same common code structure, which looks like this. Again, they're pretty straightforward. If you aren't familiar with object-oriented Ruby, I apologize. Come and speak to me afterwards, and I'll be happy to explain this in a bit more detail. But essentially, we have a class called, whatever our handler is called, replace handler name with your desired handler name, that inherits from a class supplied with Chef called Chef Handler. That provides all the functionality we don't need to care about. Handlers define a single method called report, which, as with the collect data method in Ohai plugins, is the entry point. When Chef calls your handler, it will call the report method. The way you use your handler is in client.rb or solo.rb. You have to require the file so Ruby knows about it. You instantiate it, and then you append it to the start handlers array. And when Chef Client reaches this run start handlers thing, any start handler objects listed in that array will have their report method called, and they can do basically whatever you want. We'll look at a particular, start handlers aren't, because they run so early at the start of the run, they're not the most fantastically useful things in the world unless you're doing something like notifying, IRC that a chef run started, but we will look at a specific use case for them that is very useful in a little while. The next stage of the process is to synchronize cookbooks. So Chef Client starts by getting a list of cookbook files from the server. Only required recipes, cookbook files and templates are downloaded from the server. So Chef Client knows what recipes it's going to need and what cookbook files and templates are used within those recipes, and it only downloads those from the server. So you're not downloading a whole bunch of crap you don't need, basically. It compares the stuff it's downloaded from the server, or rather the list of stuff it's downloaded from server, to the local cache, as in what you downloaded last time you ran Chef Client, and it will download anything that's changed. So if nothing's changed, essentially like if the checksums match or whatever, then you won't need to download all your cookbooks again. It will just run what it had last time. If anything has changed, it will download those, and everything else will basically be as it was before. So after this step, we come on to the run context object. The run context object it's essentially the gatekeeper for the Chef Client run. Like, it stores a whole bunch of information about what's going on, what cookbooks and resources and notifications happen. It's like the kind of central kind of in-memory data store for everything that goes on during the Chef run. Because at this point, all we've really done is downloaded some files. We haven't actually done anything to the node. And the run context object is used really heavily to basically provide all this functionality. The run context object stores a whole bunch of different stuff. It stores a cookbook collection, which is exactly what you'd think. It's a collection of all the cookbooks that you're going to be running. It stores a list of any definitions you define. Those are definitions as in the definitions folder in your cookbooks. It stores a list of events. This is another divergence, but I'm going to finish this slide and then we're going to move on to events. It stores notifications. That's as in when you have one resource notify another resource, either immediately or at the end of the run. It stores a reference to the actual node object itself. We'll come on to see later why that's useful. And it also contains a resource collection, which is empty for now, because that happens in the next step. So we'll come back to that. So on to events. This is one of those aspects of Chef that isn't actually that well documented on the internet, because not that many people use it yet. But Chef Client basically contains a event stream of all the stuff that's happening during the run that you can tap into. This allows you to respond to interesting events that happen during your Chef run without, say, having to write a handler, which basically just takes all of the run status and then you pick out the bit that you're interested in. The event model in Chef runs on a publish subscription model, so essentially you publish the notification and any subscribers get the notification. This does not involve any kind of queuing system or anything. Whoever designed this at Chef had the good sense not to put like RabbitMQ or 0MQ in there or anything and overcomplicate things. The way this works is actually pretty neat. Both the part of Chef that produces the notifications and all subscribers inherit from a common class called event dispatch base. And what that does is it defines an empty method body for every single possible event that can occur during the chef run. And there's then the actual event dispatcher, which is the bit that generates the events. That basically knows all of its subscribers. And what it does is it knows for any event that it receives, any subscribers will also have a method with an identical name. So every time a method is published to the event dispatcher, say run started, it knows that it can basically just iterate through its subscribers and call their run started method, and they can do whatever they want with that information. And this is used typically for two things in Chef. The first is formatters. Although you might not know it, you've all seen formatters before. When you run Chef Client or Chef Solo manually, the output you get on screen is produced by a formatter, which is a subscriber to the event dispatcher, and all of the text is it responding to method calls on events that happen during the run. The second thing is custom subscribers. You can basically make your own subscribers to the event dispatcher. You can create your own formatters, but we're not going to cover that now because it's not super useful, honestly, unless you really want to change the output format of Chef Client. But custom subscribers are a lot more useful, and we'll have a look at basically how to do that. So to do a custom subscriber, we basically just write a class which inherits from event dispatch base, and then we override, or overriding in this context basically means we're replacing the empty method body we inherited with a method body that does something. So in this case, we have a run started method that we want to do stuff with. So that basically means once this is registered as a subscriber, which we'll come on to, whenever an event's published, it will call the run started method of our custom subscriber class, and that could do anything. It could send a notification somewhere, it could trigger some other behavior, whatever you want to do with it. Registering a subscriber is the neat thing we can do with start handlers. So formatters, which we talked about before, they're automatically registered because there's a separate mechanism in Chef Client for dealing with those. Subscriber classes, you can write a start handler which registers the subscriber. And the way this works is this is just a start handler we inherit from Chef Handler. We have a report method. And what we're doing is we're instantiating our new awesome subscriber class that we created on the last slide. And this is where we're starting to make use of the run status object. The run status object stores stores a reference to this event dispatcher. And what we can call is the register method on the event dispatcher, which is basically what lets it know about our subscriber and adds it to this collection that will be iterated over whenever an event happens. And basically, when that happens, every time the run start method is called by the event dispatcher, our subscriber will now get that. You can do things like so as I mentioned, we use open source Chef server, which means we don't get a lot of the cool reporting stuff you get in Enterprise Chef. If you want to kind of roll your own reporting stuff, you can do it with similar things to this, because you can get, instead of just getting the entire run status as a lump, you can get everything out of the event dispatcher and you're notified as each event happens, like whenever a recipe is updated or whenever convergence starts or any of that sort of stuff. So if we track back a bit, I mentioned that we have the resource collection. And the next stage is what actually populates that. The resource collection is actually what's going to be executed on your node. That's what's actually going to be used to make the changes. And the resource collection basically involves loading into memory all of the stuff you have in your cookbooks, like recipes, definitions, resources providers, libraries, and so on. These are loaded in an extremely specific order. And if you have issues where, for example, you can't use attributes in a library, this will hopefully explain why that's the case. The first thing that's loaded are libraries, because libraries are essentially supporting classes you can make use of in providers and recipes and so on. Next, attributes are loaded. So attributes are loaded after libraries, which means libraries cannot refer to node attributes. So attributes are loaded next because they're typically used by everything that follows. Next, any resource, so lightweight resource providers, heavyweight resource providers are loaded. They often make use of attributes and they often make use of libraries, so it makes sense to load them here. Then definitions are loaded. That's anything in the definitions folder. Definitions can themselves use resources and providers and libraries, so they're loaded here. Finally, your recipes are loaded, which actually make use of all of that stuff. So once this has happened, we've populated our resource collection. This now means we're in a position to actually do something to our node. We have an ordered list of everything we want to actually do to the node. So now we come on to the converge stage. This is the first step of the run process. It's the second box from the end. This is the first step that actually changes anything on your node. Up until this point, if Chef Client craps out, nothing has changed on your node, even though it's right near the end of the process. And basically what happens during this step is we apply the resource collection to your node. It iterates, because we have it ordered, because order matters. We iterate through the collection. It basically does its thing, cookbook files, packages, directories, etc., does all of that stuff. And then we come on to the finalize step. The finalize step actually consists of two pathways, if you will, depending on whether the run was successful or failed. If at any point previous to this the run failed, it will jump directly to the kind of failure logic path here. But in the event there's a successful chef run, it will save, remember we created the new node object right at the start with our new attributes merged in, it will save that back to the chef server. So that means when we next run chef, we're loading our new modified node object. And it'll also run any report handlers. We'll come on to this once I finish the slide. If it's a failed run, it'll run any exception handlers, and then we have our little sad Unicode poo character because everything's gone to shit. Report and exception handlers, because they're now running at the end of the run, they have access to all this cool stuff that we created during the run, like the run status object that has all this information about what actually happened. And what this lets us do is stuff like this. So this is another handler. It has a report method. What we're actually doing here is we're implementing functionality for both a successful and a failed run in the same handler. The reason we can do that is because we now have access to whether the run was successful or failed. The run status object contains a whole bunch of different methods, including success ? And failed ? If run status.success, that means the run was cool. Do a happy dance. Otherwise, if the run status failed, and that basically means something happened somewhere that caused an exception that couldn't be recovered from, then that makes us a sad panda. Same way as start handlers, the way we actually make use of these is we require the file, we instantiate our handler. You'll actually notice here we're adding the same object to both the report handlers and the exception handlers arrays because we have logic to tell which one we should be running when the report method's called. You don't have to do this. You can actually just you can actually have an entirely separate handler that doesn't have any logic in the report method. It just does say, if you know it's going to only be an exception handler, you can just say post a gist in the IRC channel with the exception and backtrace that you got. Then we have exception handlers. So exception handlers and report handlers, two separate arrays, and you can either mix them as we saw, or you can go back and implement them separately. So now we're going to go back and take a little bit more of a detailed look at the run status object. We've touched on a couple of things it can do, but there's basically a whole bunch of really useful stuff it can do. The run status object, as we mentioned, is accessible to handlers. So in your handlers, you can tap into all of this information the run status object stores, like every single resource that was executed in the node, whether the run succeeded or failed, run status and timings. You can use this to give you profiling information. I'll mention that again in a second. You can get any exception and any backtrace that actually caused the run to fail. That's right in the run status object too. What we do with this at Etsy, for example, is when we have an exception handler, which when the run fails, it posts a gist into an IRC channel called chef, and we can just click on the gist and see what exception happened on the node without having to log on to it, which is kind of cool. You also get a list of both all and updated resources. So what this means is you get a list of all the resources that were scheduled to be executed on the node, and you also get a list of the ones that changed. So some of the resources, because chef is idempotent, some of the resources won't have done anything. There's nothing changed that they needed to do anything about. So you can distinguish between your total list of resources and the ones that actually needed to do something that run. And you can access both of those sets of information. You can also access the run context object that we looked at earlier that has all this stuff like all of this stuff that kind of monitors what goes on during the chef run, like cookbook collection and all this cool stuff. And you can also access the node object itself. This, again, it's a reference to the same object here. So in your handler, you can do things like introspect into the node and figure out maybe it failed because you expected an attribute to be there that wasn't, and maybe in your handler you can print this attribute had that value or something. Now at this point, I want to put this slide up. Don't fear the code in Chef. You might feel like you don't know enough Ruby to do this stuff, which may be the case at the moment, but you can learn. Chef is one of those tools. Because you can do so much stuff with it, which hopefully I've given you a little flavor of as I've been talking here. Essentially, the more you understand about how Chef works, the more that empowers you to make Chef work for you. So what I've done here is I've listed a couple of source code files. If you have the interest, you can go and look at them. And these are all things we've talked about. So there's the handler class, which is what all your handlers inherit from, the chef handler class we mentioned. There's the run status, the class definition for the run status object. What that does, you can go there, and you don't need to understand the code, but you can go and look at the method definitions and see these are all methods that I can call on the run status object from my handlers. And you can see all this cool stuff that it tells you. Then we have the run context object as well. Again, you can go look at the method definition, see all the things it has, see all the information it stores. And you have the event dispatch base class. That only contains empty method bodies. If you don't know any Ruby, you can definitely read that one. There's nothing in it apart from a class definition and some method bodies. And what that does is that tells you all of the supported events. If you look through that and you're like, oh, hey, Converge started. I want to do something when the convergence stage starts. You go look for the method name, and then you write a subscriber, which defines a Converge started method, and you do whatever the hell you want with it. So like, This I would say is very important. If you don't know if you know enough Ruby to write cookbooks, but you don't know object-oriented programming, like you're not familiar with classes and Ruby gems and things like inheritance and so on, I would encourage you to learn. I'll come on to a way you can do that a little bit later a little bit further down the line. But I would encourage you to go and look at this stuff. Like the more you understand about handlers, the better you can write handlers. If you want to write a handler and you're sat there thinking, oh, I wish I could tell how the run succeeded or failed. Turns out you can, but because it's basically impossible, although Chef are making massive strides in improving documentation, they can't document literally every single thing you can do with Chef, or at least not very quickly. There's just too much of it. So like, go spelunking in the code. Like, you'll learn a crap load as well. You'll find out a lot more about how Chef does this stuff. I'll come on to how exactly later on, but the reason that I did this talk was because I had reason to go spelunking in the Chef code. And up until that point, I didn't even know the event dispatcher existed. The event dispatcher isn't really documented in the Chef docs because it's only got a couple of particular uses. Formatters are kind of documented, but the event dispatcher isn't documented at all. The only reason I know that's there is because I was looking through the code for something else, and I noticed it, and then I was like, ooh, this is cool. What does that do? And it turns out it does all this really cool stuff you can tap into. What? So that's a lot of we've covered a lot of stuff there, and unless you're one of those people who's particularly comfortable with Ruby, has particularly well-defined ideas for what exactly you're trying to do with Chef, you're probably sat there thinking, well, how the fuck am I supposed to know what to do with this? Like, do I want handlers? Do I want Ohai plugins? Do I want event dispatcher stuff? Like, what am I supposed to do now? I've told you how to do a whole bunch of stuff, but I've kind of been like, go forth and do what you want with it. So what I'm going to do now, because I believe in responsible presenting, is I'm going to try and help you. Just give you some kind of ground rules to try and help you make those decisions. Like I said, I can't tell you how you should be running your Chef infrastructure or what customizations you should be writing, because I don't know what you're trying to do. You're the ones out there who know what kind of customizations you might need to solve your problems. All I'm trying to do is get those creative juices flowing and give you some ways you might be able to solve these problems. So the first criteria for customization I want to talk about is simplicity. When you're trying to solve a problem and you're thinking of a solution, ask yourself, is it making things simpler for you? If all you want to do is figure out if a run failed and post a notification somewhere, you probably don't want an event dispatcher subscriber, because a handler is a much easier way to do that, and it already has all the information you need. Modularity. This applies particularly to recipe customizations, which we haven't touched on here, but that's things like resources and providers and so on. Is this improving the modularity of your code, or is it introducing a whole bunch of code spaghetti that you don't really want? Like, is this going to make your code more modular and composable and reusable? Visibility. Is this improving your visibility into your infrastructure or your Chef code or your recipes or whatever it is you're trying to get visibility into? Just to give you a kind of example of this, at Etsy, we only have like 2 or 3 handlers. We have a handler that posts some statistics to Graphite on things like elapsed runtime on our nodes, so we can have a histogram to see if there are any outliers that are really long runtimes. We have a graph for like average resources updated, so we can see if something weird's happening. All of a sudden, all these resources are being updated when they should have been converged already. So we have one that sends stuff to Graphite. We have one that posts the failures to an IRC channel. And we have one that posts stuff to, it's basically like an internal event logging thing called Eventinator we have. It's like one of the only things we have that isn't open sourced, which is kind of annoying because it's the one thing I'm talking about here. But yeah, basically, like we have the handlers we need to get visibility into our Chef stuff. we're not doing those are the ones we have because those are the ones that are giving us the visibility we need. Is it making your infrastructure code more maintainable? If you introduce this brand new shiny event dispatcher subscriber, are you the only person in your organization who knows how it works? Have you just gone on holiday and you didn't document that thing? Is somebody else going to have to try and figure out how this works if it breaks, particularly if it's depending on an external service? Are you suddenly going to get weird errors popping up in your chef runs that no one knows how to diagnose? If the answer is yes, you're probably not making this maintainable, and that maybe should give you a little pause. Just think, do we really need to do this? Should we maybe do this a bit more comprehensively? Like, this is something to think about. Is it helping your scalability? Like, as I mentioned, Etsy are kind of middling-sized website in the grand scheme of things. We have like 1,500 servers. We're not going to lose servers. We're going to get bigger, ideally. And so will all of you. Some of you may be from massive companies like Google or Facebook. Some of you may be from tiny companies that are running like two cloud nodes on Amazon. In an ideal world, you're very, very unlikely to get smaller infrastructure. As your businesses scale, so your supporting infrastructure will scale. Are these customizations you're making going to help that process, or are they going to hinder it? When you come around to move in, so one thing we had to deal with recently was moving into a separate data center, when a lot of our chef logic was predicated on only being in one. And that was fucking horrible to deal with. It took a long time to fix that because we had all these assumptions based on our nodes having NY4 in their FQDN. All of a sudden, some of them had a different DC name in the FQDN. And then we had to add all this abstraction stuff for like, well, okay, so what we ended up doing was we now have an Ohai plugin, which checks our asset tracking system and sticks an attribute in there that says what data center the node's in. Ohai plugin. It's very, very simple. It's like 6 lines long. I can show you the source code later if anyone wants to see it. But that's both helping our scalability. And it's also making things a lot simpler because we had all this recipe logic that from legacy cookbooks and so on that was kind of horrible. So we've gone through like a bunch of stuff here, and we've only touched on a very small amount of the stuff you can customize in Chef. And I have a lot of opinions on this, and I couldn't fit it in a talk, so I'm writing a book about it as well. The book's due out in November 2014. You can pre-order it now, johnlive.es/book, vanity URLs for the win. So you can basically pre-order the digital copy, and that gets you the half that's done at the moment, and then you get updates, and then you get the full one for free when it's out. They also have a preview copy on the O'Reilly stand at the moment at $3.55 today. If you go there, for some reason they want me to sign half a book. If any of you want half a book signed, that's where you want to go. The first 25 people at the O'Reilly stand at $3.55 get a free print copy of the half of the book that's done. So that gives you it gives you the chapters on all of the stuff that we've covered here, plus the chapter on knife plugins and the chapter on just enough Ruby for customizing Chef, the Chef internal stuff. So all the stuff we have here, plus knife plugins and some Ruby stuff. The bits you don't get are the chapter on like resources providers and stuff, because I'm writing that one now, and the chapters I haven't written yet, because it would be kind of weird if you could get them. So there are 25 copies of that will be available at $3.55 if anyone wants them. If you're really keen, I can sign it for you. You never know, maybe my signature will be worth something one day. Hedge your bets. And office hours, 3:15 in the Marina Room. These are my contact details. That's my Twitter. That's my website. That's my email address. Ping me an email anytime if you want to talk about stuff. I also have Coda's Craft stickers. That's our engineering blog, codascraft.com. Stickers, the same logos on the t-shirt. If anyone wants one, come see me. That's basically all I have. Does anyone have questions? We have a few minutes. Right at the back. Speak loudly, please. Chef them out. So the question was, how do we get those plugins where we're mentioning the path? How do we get those onto our nodes? In our case, we chef them out. You can actually, there's like a little trick you can do where you basically chef out the plugins and then you notify a resource which makes Ohai rerun, effectively reloads the plugin and runs again with your new plugins. That's how we do it. There are probably other ways to do it. That one works for us pretty well. It's quite easy. Again, if you want to see the exact code that does that, I'll show you the cookbook that does it we have. Any more? Here's a microphone. I actually don't know. So the question was whether the event handler runs on a separate thread. I don't know, is there anyone from Chef who can answer that one for me? They're blocking. There we go. Is there one over there?
Yeah. Is there a way to prioritize the order in which events get fired?
Is there a way to prioritize the order in which events get fired? Well, the kind of cheating answer there is because order matters. The ones you want to get fired first, you put first in your run list.
Well, I'm just saying if you have something that somebody else is using something.
So basically, the events that are fired, they're fired whenever Chef does something. So like the events are things like Ohai started, Ohai finished, Converge started, Converge finished. Like adding custom events is a bit trickier. So the events there are things that just happen normally during the Chef run. So the only real influence you have over the order is the order in which the actual resources and recipes are running. Otherwise, it just happens when it happens during the run.
Thank you.
Anyone else? Anyone else? Over there?
There was variables in Chef a while ago. I think they were gone in Chef 8 or something. But yeah, you can achieve the same functionality with the run state. It's more like a philosophical question. Why do you think Upscode is hiding those gems from us?
So the question was, I think there were variables, and do you mean why are things like the run status not more visible, or?
I mean, it's not documented.
Oh, okay, so why are these things undocumented? Mainly because, in my opinion, I mean, I don't write the documentation, so I don't know. If I had to speculate, I would say because a much smaller proportion of the Chef community needs to use the run status object than needs to be able to write nice cookbooks. And like, if you try and learn, basically, I found from when I started Chef, the learning curve goes like that, then like that, then like that again. And the Chef documentation at the moment is focusing on the first that. This stuff is focusing on the second that, and if Chef documented all that stuff, new people to Chef would look at all the documentation and they would cry and think they were never going to understand it. Like, you have to separate out, this stuff is more intermediate advanced level. Like, if you're brand new to Chef, I would really recommend you go and do the Learn Chef stuff and like the Chef table thing that was talked about earlier before you start doing this stuff. This stuff is for people who kind of know how to use Chef, or they know how to write cookbooks and things, and they want to start doing more stuff. So that's, if I had to guess, why I would suspect it's not as well documented as, say, writing LWRPs is. Anyone else? That's it then. Thank you.